Hello, students. Oh my goodness, I can't see a thing. Whoa, I can't. Oh, good. Found my glasses so I can see much better. Today, what we are going to do is talk about AM4 lesson number 9, which is how to graph parabolas. We talked yesterday all about the shapes of parabolas, properties of parabolas, but today we're going to now talk about the properties of, how to graph them given an equation. Very important that we move on to this. And these parabolas are going to have a certain characteristic to them. And we'll talk about that when we get there. Okay, so we are going to talk today, again, about graphing. Let's see here. Wait, we're in this mode. There we go. All right, AM4, lesson 9, graphing, parabolas, quadratics in factored form. Okay, so there'll be a couple key points of learning. We'll try and call those out. But we're going to look at a graph here, and we're going to say we're going to graph f of x. Oh my goodness, what does that mean? Let's not get freaked out by that. Equals x squared minus 6x plus 5. Well, we know, because we are comfortable mathematicians, that f of x means nothing more than y equals x squared minus 6x plus 5. This f tells us it's a function, and it tells us it's a function, and that this, it's a function, of x. Well, you can kind of look at this guy right here, and you can kind of see that this is a function of x, because you can see your x's on the right, and you can see that if you put in any x, you can probably presume that if you put in any x, you'll get out one y. You can't get multiple y's out for any x value. But f of x kind of reminds us of that, and mathematicians think it looks cool and makes them look smart. So that's why they use it, I guess. All right, now what we're going to do is, we learned how to factor these things. So we're still going to need to factor, and then we're going to make some interesting observations. So let's first start off with factoring this. So we're going to use our big X, and we're going to put our -6 up here and our +5 down here. And we need two numbers that multiply to 5 and add to -6. So let's put our -5 and -1 here. Okay, so our answer, if we factor this, guys, we're going to get y equals x minus 5 and x minus 1. All right. Now, there's some interesting things we can also do here, and we'll make a chart over here, and we'll say, well, if x is this, then y is that. Well, we know something really cool about this guy. Now, bear with me. We've learned this before. I'm just connecting the dots for you. So if x is 5 here, then what is y? So we're going to take 2 points, and we're going to say, well, x is 5. Let me do it differently. Let's write 1 and then 5. Let's do it like this. And you'll see why I wrote them like this. So if x is 1, well, we can use the zero product property here. So if x is 1, we get, well, 1 minus 5 times 1 minus 1. Well, that's -4 times 0, and that's 0. So if x is 1, y is 0. And if we can probably guess what happens if x is 5. Well, x is 5, y is also 0. So if we are going to graph this function, we already have 2 points that work. And what are these things called? Let's just put them up here for a second. Well, if we graph them, we go 1, 0, and we go 5, 0. Oh my goodness, what are these called? These points, if they hit the x-axis, these have a special name. These are called x-intercepts. Oh my goodness, things are starting to click, maybe in your head. X-intercept. So we have two magic points. So let's look at this. I want to remind you the characteristics of all parabolas that we've looked at. They have x-intercepts. Not all of them have x-intercepts, but we're going to remember we're talking about, and I reminded you this last video, and I'll tell you about this for this section before the next test. We're going to be talking about parabolas that have x-intercepts, at least one. They also have a vertex and an axis of symmetry. Well, what do we know about these 2 points here? If this parabola has an axis of symmetry, it has to be right down the middle of these two. Because these points will mirror each other. Okay, so if this point here is 1, 0, and this point is 5, 0, we actually have everything we need to know to find this axis of symmetry. Well, could it be at 2, 0? No, because it's got to be halfway. The axis of symmetry is halfway between my x-intercepts. This is a key point. So if it's halfway between, it's right here at 3, 0. So this line has to be x equals 3. So I know that my vertex is at a point somewhere along here where x is 3. Okay, so I know that I can just put this in and I can say, well, cool. Let's find the point where x is 3, and then we're going to have our vertex. Because it's got to be on this line. So let's put a 3 in for my x here, and we'll go, well, y equals 3 minus 5 times 3 minus 1. So that's y is negative 2 times 2. Negative 4. So this is my vertex. I'm cooking with gas. I have 3, negative 4. Which is awesome. So there's my, all right. So I'm going to pause it right here. I'm sorry. We're going to stop the video right here. I have someone at my door, and we're going to have an AM4 lesson 9, lesson 9B. Sorry about that. We're just going to stop the video. Okay, we are back to lesson 9B. Let's get back to it. Sorry for the interruption. Here we are. We have figured out where the 2 x-intercepts are by using our factoring. Again, here's our equation. And then we realize that our vertex is always halfway between our x-intercepts. Now, there's another interesting thing that you can find, and that would be where we could find the y-intercept. So we found our x-intercepts at 1, 0 and 5, 0. Oh no, we're not done. We haven't found our vertex. Oh yeah, we did find our vertex. So we're at 3, negative 4. So we have 3 points. And remember, this is going to definitely open upward. You can see if this is the vertex and we have these 2 points, it's going to open up. So this is a minimum. This is the bottom. Now, one other interesting point we can find is a y-intercept. A y-intercept is where x is 0. So let's find our spot where x is 0. Let's put a 0 in to our equation, and we'll say y equals 0 minus 5 times 0 minus 1. That equals -5 times -1, or equals 5. So at 0, we have 5. And this is taking shape really nicely. So we go right up here, and we got 0, 5. Also on our parabola. Now, there's a very key point that we can use, because our y-intercept is 0, 5, and we know about mirroring. So I want you to think about this axis of symmetry mirroring and where another point has to be. If this is 3 away, right, because we got x is 3 and this is 0, 5, then we have another point right over here, another 3 away at 6, 5, right? This is x is 6 and y is 5. So now we have another point. So now we have 5 points, and we can nicely graph our parabola. My hand isn't perfect, but whoops. I don't know. Mr. Lipscomb, what is going on with you? That's all right. If you do, you do something like that, I'm okay with that. So that's kind of our parabola here. This is our minimum down here. And the interesting thing is it's always kind of round. It should really be kind of rounded towards the bottom here. Okay, so that's our key. So I want to remind you of our steps here. So let's remind ourselves of our steps. And let's write those in kind of this color. So first we're going to factor, and then we're going to find our zeros, or find our x-intercept. We call them zeros. Sorry, you'll see why later on in this unit. Find our x-intercepts. They use, and then we find our vertex. Or no, we find our axis of symmetry. Axis of symmetry, which is halfway between x-intercepts. And then we find our vertex by plugging in our axis of symmetry value for x. So again, our axis of symmetry was x equals 3, so we put a 3 in for x. That's step 4. We plot our axis of symmetry, and then 5, we find our y-intercept by plugging 0 for x, and then 6, or 5a, we'll call it 5a, we mirror our y-intercept. And we're going to do these same points, the same steps, and we're going to do one more example. So here's our next example. Just a sec, we're going to open one more. Here, whoops. And our example will be y equals 2x squared. And I'm going to ask you here to remember another concept that we've already used. So in this case, whoops, this isn't going to be the right graph, by the way. We need to use a different graph. Let me go and create that graph for us. Here it is. I kind of know where the answer is, so I'm kind of cheating a little bit. Okay, so the first thing we're going to do when we factor this, can we just factor this? I think some of you are looking for a 4-step factoring, but the right thing to do is always, always, always look for GCF. Our friend GCF first. And let's do that. So if we GCF factor this guy, we get y equals 2 x squared plus 5x plus 6. Okay, now I'm feeling a lot better. We're going to, let's just do our big X here. Multiply to 6, add to 5. That would be a plus 3 and a plus 2. So this is kind of, step one. We're GCF we're factoring. So we get y equals 2 times x plus 3 times x plus 2. Now let's move on to step 2. Step 2 is find our x-intercepts. And that's easy, right? X equals, and we can solve it. We can say, well, x plus 3 equals 0, or x plus 2 equals 0. So subtract 3, x equals -3, or x equals -2. So those are our x-intercepts, -3, 0, and -2, 0. Okay, so that goes here and here. Oh my gosh, are we gonna have to do another? Oh, I got people at the door again. Oh my goodness. Shoot, I'm sorry. We're gonna have to go build a C version. Okay. All right, I'm sorry. Sorry. Just okay, we're back again after another interruption, but let's see. Hopefully we can make it through this last of the video. So the second example, I should say. Let's just finish up this second example and then we'll be done. So we find the x-intercept. Now the neat thing that we do, that we know to be true, remember point 3 is we find the axis of symmetry. And the axis of symmetry is always halfway between the 2 points on the two x-intercepts. So in this case, we have -3 and -2. So our axis of symmetry, it's going to be a fraction. So it's x equals -2.5 or -5/2, right? So we know that the mirror line is going to come right through here. So let's just draw that line right there. And then we need to plug in this -5/2, and we need to see where our where our vertex is. So we're going to say y is equal to, we need to go back to our original formula, and we say, well, y is equal to 2 times -5/2 plus 3 times -5/2 plus 2. Well, let's do our math, write it all out. -5/2 plus 6/2 times -5/2 plus 4/2. So that's equal to 2 times, well, that's a half, and that's -1/2. So our answer is, well, 2 times a half is 1 times -1/2 is -1/2. So our vertex, so we're finding our vertex. This is point 4. We found our axis of symmetry. This is finding the vertex. So it's at -1/2. So it's -5/2, comma, -1/2. This is our y value, and this is our x value. So let's plot that. Negative 5/2, negative 2.5, comma, negative 1/2 is right here. Negative 5/2, comma, negative 1/2. So now we have 3 points. Now we need to find our, let's go find our y. So now we're going to find our y-intercept. And to find our y-intercept, we just simply put a, plug 0 in for x, right? Because we're looking for the point where the parabola hits the y-axis, and that's where x is 0. So we say, well, y is equal to 2 times 0 plus 3 times 0 plus 2. That's 2 times 3 times 2 is equal to 12. So our y-intercept is 0, 12. Uh-oh, well, that's way the heck up here. So we can't really put that on our graph. Our y-intercept, man, way up there. So what can we do? We can use another point. So now we're going to go into modified mode and use number 6. We can just use, let's just figure out where negative 1 hits. Let's use another point. So we're going to use negative 1. So let's use our formula and say y equals 2 times negative 1 plus 3 times negative 1 plus 2. So that's 2 times 1. This point's going to work out a lot better. So that's equal to 4. So our x value was negative 1. Our y value is 4. So we have a point of negative 1, 4. So negative 1, 4 is on our parabola. And now we can still use our mirror technique to find another point. So if this is, let's see, this is negative 1. We have to go from negative 1 to our mirror. This is, remember, this is x equals negative 2.5. So this is negative 1. We got to go 1.5 over this way. So there's 0.5. There's 1. So we're going to go right to here. That's a mirror. So we went 1.5 this way and 1.5 this way. And we can draw a nice curve like this. And that's going to, again, that's going to go up to 0.0, 12. But it's not, we don't have that on this graph. Yeah, let's just do it like this. Oh, you know what we didn't do last time? We didn't do happy cat. So we got our happy cat. So we followed our steps. We have now successfully graphed two parabolas using the standard 5 and optional 6-step process. Hopefully you have those written down, and we will have done this in class. So there we go. Three videos, kind of the length of one. We will talk to you. Oops, we got to sign off here properly. Let's sign off properly with a nice clap. We'll see you in class.